Hi, and welcome back to Calus Prep. Let's take a look at a few examples of easy and medium questions we'll encounter on the SAT. In the figure above, the heavy segmented line from P to R is composed of line segments that are parallel to either OR or OP. If the length of OR is X and the length of OP is Y, what is the total length of the heavy broken line from P to R? Okay, well, we're told that each of these segments is parallel to either, which means that if we drop down these segments right here that are parallel to OP, they should add up to the length of OP, which is Y. And if we do the same thing for the vertical segments that are parallel to OR, drag them over, we realize that they add up to a complete OR, which is equal to the length X, which means that combined, these segments are going to be X plus Y, choice B. What is the solution set of this system of equations? And we're given x squared plus y minus 1 is equal to 0, and x minus y plus 1 is equal to 0. So it looks like the addition and subtraction method would work best because of that equal and opposite y that we've been given. So if I add the second equation to the first, I will have x squared plus x equal to 0, which means that x times x plus 1 is equal to 0, which means that x is either equal to 0 or negative 1. Now let's plug that into either of our equations to find out what y equals when, for example, x equals 0. 0 squared plus y minus 1 is equal to 0, so y equals 1 when x equals 0. Let's do the same thing when x equals negative 1. So negative 1 squared plus y minus 1 is equal to 0, which means that 1 minus 1 will cancel out, and that y is equal to 0 when x equals negative 1. So these are our solutions, 0, 1, and negative 1, 0, which looks like answer choice C. Solve square root of 13 minus x is equal to x minus 1. All right, first off, I want to square both sides to make this more manageable, leaving me with 13 minus x is equal to x squared plus, or rather minus 2x plus 1. Add x and subtract 13 from both sides to whittle it down to x squared minus x minus 12 equal to 0. Factor out that quadratic, and it looks like x minus 4 and x plus 3 is now equal to 0. So x is equal to either negative 3 or 4. And I've got enough time left over to check my work, or at least my answer solutions to the original equation. So let's find out whether or not this works when x equals negative 3 and 4, which looks like choice B, by the way. So square root of 13 minus a negative 3, is that equal to negative 3 minus 1? Square root of 16, is that equal to a negative 4? Plus or minus 4 can equal negative 4. So yes. All right, let's check when x equals 4. Square root of 13 minus 4, is that equal to 4 minus 1? All right, well, square root of 9, is that equal to a 3? Positive or negative 3? Yeah, that equals a positive 3, so choice B was correct all along. Copper production increased at a rate of about 4.9% per year between 1988 and 1933. In 1933, copper production was approximately 1.08 or 1.801 billion kilograms. If this trend continues, which equation best models the copper production P in billions of kilograms since 1993? We also are told to let t equal 0 for 1993 for this exponential function, and we know that this trend is going to continue of 4.9% increase per year, so 100% plus 4.9 is 1.049 times x, and that's going to be the next year's production starting at t equals 0. So let's cancel out anything that doesn't look like that. All right, they all have 1.801, so we cancel out A and B because it's not being multiplied by the right increase, nor is D, which leaves C, looking like what we had. If x plus y equals 5, and x squared plus 3xy plus 2y squared is equal to 40, find the value of 2x plus 4y. Okay, well, I'm going to take that second equation and try to factor out that quadratic on the left-hand side. And it looks like to get the first term, I'll have x and x. We've got positives all the way through, which leads me to believe it's going to be x plus y and an x plus 2y to get that 2y squared for the last term. Now let's find out whether or not this is actually equal to our original quadratic. So we'll do first terms, followed by outside terms, followed by inside terms, and finally last terms to get x squared plus 2xy plus xy and plus 2y squared. That does look to be the same once we simplify that 2xy plus xy. So let's go ahead and realize that this factored form is equal to 40. And when we've set it equal to 40, we will remember that x plus y equals 5. Substitute that in to our factored binomial expression, so that 5 times x plus 2y is equal to 40. So x plus 2y is going to be set equal to 8. Now, that looks very much like that 2x plus 4y, just half as much. So if I multiply both sides by 2, I should find that 2x plus 4y is equal to 16. So the answer is 16. And it looks like we came up on 5 minutes and 50 seconds, which is divided into 5 questions, averaging a total of 1 minute and 10 seconds per question. Not too bad. As always, I want to thank you so much for stopping by Calais Prep. My name's Ricardo Calderon, and we hope to see you again soon.